All right, so let's look at this. We have hydrocarbons. Like I said, we want to look at how to name organic compounds. So it's quite very compact. It's large. We want to start with hydrocarbons. Hydrocarbons are compounds comprising of only carbons and hydrogens, right? So in terms of classifications, we have two types of hydrocarbons: the aliphatic and the aromatic. Aliphatics comprise of alkanes, alkenes, and alkynes, as well as their cyclo compounds. And then aromatic is benzenes and their derivatives. So I want to start with alkanes. Class. All organic compounds derive their names from alkanes, all of them. Because when we want to name alkanes, we always make reference to alkanes. We want to name alkynes, we make reference to this guy, carboxylic acid. So once you understand how alkanes are being named, at least you've gotten the basics. All right, so before we proceed, alkane has a general formula of Cn, H2n plus 2, where the n is the number of carbons. I'm very sure a lot of us are familiar with this already. Now, it is saturated. When they say a compound is saturated, it simply means that it does not have any double bond or triple bond. So it's single bonds all through. So the first if this n is number of carbon. So if the number of carbon in an alkane is 1, this guy becomes C. I'm not going to write the 1. 2 times 1 is 2, right? Plus is how many? 4. Now the structural formula of this guy could still be CH4 and the name is methane. This is a gas. If n is equals to 2, this becomes C2. 2 times 2 is 4, right? Plus is how many? 6. Class, in terms of the structural formula, this is what I'm going to do. How many carbons do we have there? 2 carbons. I put this and I put this. You know, so based on what I taught us previously, how many lines can we see this carbon is having? 1 line, right? So how many hydrogen will be here? How many will be here? So that is why this guy is CH3, CH3. So I can now clean it up and write it to be CH3, CH. There is a bond between those two guys, right? Now this guy is methane. Now if the number of carbon is 3, it becomes C3H8. Once again, it's more like saying, okay, let me write it here. For 3 carbons, it's like say 1, 2, and 3, right? This guy has 1 line, so here will be what? 3. Here has 2 lines, here will be what? Here will have it's 8 hydrogens, right? So this now becomes CH3, CH2, and what? CH3. Now the name of that guy is what? Propane. Now, if the number of carbon is 4, here becomes C4H10. If you actually follow this concept, 2 times 4 is 8, plus 2 is 10. So this is what I'm going to do. How many carbons do we have here? 4. So if you follow that, this is 1, 2, 3, 4. Here will be CH3, right? 2 bond, CH2, CH2, and 1. So I'll remove the lines because I want it in a condensed form. So this is CH3, CH2, CH2, CH3. You know so. Now this is what? If here is 5, this is C5. Class. Here, if you notice, initially there was no CH2 there. But there is CH2 here. You know so. How many CH2? 1. Here, now how many CH2 do we have? Now, for 5, how many CH2 do you think we're going to have? 3. So I cannot keep on writing CH2 because it's getting longer, right? So I'll condense it. So this is more like saying CH3 is also. I'll open a bracket. How many CH2 will I put here? 1. I'll say CH2. How many places? 3. Now this stuff is more like saying CH3, CH2, CH2, CH2. So this guy, we now took one of them and actually put 3. Right? It shows that it's happening 3. So what is the name? pentane. Now this guy, it has C6H14. So this is CH3, CH24, CH3, hexane, C7H16, CH3, which is what? Now 8 CH. This is CH3, CH2, 6. H 9. That's dot. 11 will be what? What will it be? Now, this is a phase 12, this is a phase 11. 12 will be dodecane. So if you look at this, now these are, note, these are the names of unbranched alkanes from C1. So all of they are all unbranched, which are they are the normal alkanes. Normal alkanes are the ones that are not branched, right? So these are all the straight chains. So for you to actually name any, for you to be able to name any branched alkane, you must always make reference to this. Because for example, you're being given something that is branched at carbon 2, the rule number 1 says identify the parent chain. So the parent chain should actually fall amongst any one of these. If it is 5-carbon alkane, 5-carbon alkane should be called pentane. So we cannot proceed to naming branch without knowing how to name the straight. So this is the basis upon which the branch chain will be named. So I will leave this on the board, and then we proceed with the rules on how to name the branch. So this is basically names of unbranched alkanes from C1 to C11. So take note of what I did here. I only condensed this structure further because if I had not condensed this guy, this entire board may not be enough.
Now let's name branch chain alkanes. Please put down the rules. Branch chain alkanes. How do we name branch chain alkane? Rule number 1. Identify the parent chain. Identify the parent chain. Now most times some textbook can call it principal chain. Please, I can clean up this, right? Identify the parent chain, full stop. This is the longest continuous carbon chain. Identify the parent chain, full stop. This is the longest continuous carbon chain. Now what this simply means is that If I have something like this, let's say I have CH3, CH2, now look at this. Because for each of the rules, I'm going to be explaining it. If I have something like this, class, the parent chain must not always be the one on the horizontal. Because a lot of persons, if I ask you the parent chain, you say 1, 2, 3, 4. Automatically, this becomes a branch. Nope. Branch is not always the one that is down or the one that is up. The one that is by the side can even be the branch. So what we mean by longest continuous, if I have a rope if I have something like this, imagine if I have a rope that looks like this. Class, you know that this rope here, maybe if I put my hand here and put my hand here and stretch it, this guy goes up, becomes a branch. Right? So that's basically what this thing is. So the parent chain is the longest. Once you miss the parent chain, obviously whatever you're going to get as your answer will be wrong. So the parent chain is not 1, 2, 3, 4. It's not. The parent chain, if you look at it, let's count from carbon edge to carbon edge. The one that is the longest becomes the parent. Now the carbon edge, we have 1, 2, and 3. So count from 1 to 1. So this is 1, 2, 3, 4. We have 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Look at what I did here. I labeled this edge, labeled here, labeled here. 1, 2, 3, 4. The first one. 1, 2, 3, 4, 5, 6. The second guy. 1. I can no longer say 1, 2, 3, 4 because it's the same thing like the one I did previously. So I'll now say 1, 2, 3, 4, 5. Class, between 4, 6, and 5, which of them has more carbon? So the one that is 6 becomes the parent chain, is it not so? So this now becomes, I'll now circle it. Anything that is not part of this circle becomes a branch. And obviously, what is now the branch? CH3. That's a branch. CH3. Imagine you're asked to name this compound. The first thing you're going to do is to get the parent chain. The parent chain, some persons can call it principal, is the longest continuous. Longest simply means, continuous simply means it must not necessarily be straight. It can bend as long as it is still what? Moving. So, in order for us to understand this better as a new learner, just come to the edge and asterisk all the edges you can find. Count from one edge to the other. Don't repeat a particular edge twice. So I'll count from this guy to this guy. 1, 2, 3, 4. So counting here, the carbon chain is 4 carbon. I'll now say let's count from this edge to this edge, which is equivalent to saying from here to here. 1, 2, 3, 4, 5, 6. This is from here now to this guy. 1, 2, 3, 4, 5. So between 4, 6, and 5, which of these is the longest? 6. So 6 becomes the parent chain. Every other thing apart from that 6, anything that is not part of the 6 carbon chain is now a what? A branch. So you circle this guy. This is what I'll do. You see this stuff I have here? Do you know I can rewrite this stuff? This same chain. If I had done it this way, I bet you a lot of persons will not find it difficult. If I said CH3, CH2, CH, this CH3 now, I put it where? Up. And I'll say CH2, CH2. Do you know this is the same thing as this? It's the same, just like what I told us. Imagine this is a rope. If you hold this place, you stretch it. This guy will now do what? go up, which is what we have here. So that is why if you're asked to name a compound, always identify your parent chain. In this case, 1, 2, 3, 4, 5, 6. Now, class, the name of this parent chain, how do we name it? 6 carbon alkanes. 1, 2, 3, 4, 5, 6. 6 carbon alkane is what? So the name of this parent chain is what? This is not the name of the compound. This hexane is not the name of this compound, right? But the name of the parent what? Chain. Now, but if you look at this guy has a branch point, is it not so? So that is, we're going to look at that in rule number 2. The first rule says identify the parent chain, which is the longest continuous. Rule number 2 now says identify the branch / substituents. Now, class, please pay attention. Branch points can also be called substituents. Substituents can be in a form of carbon and hydrogen, in which case we're going to call it the alkyl groups. So I'll say substituents can be alkyl group. They can be halo. They can be nitro. Now these are the 3 common substituents that is found in alkanes. OH, if OH is present in an alkane, it's no longer alkanes. That is now an alcohol. So we're looking at substituents that when they are present, the compound will still be named as what? Alkanes. These are the 3 major substituents. This does not, like I said, this is not the only substituent we have. Those other higher substituents, if they are present, those compounds will no longer be named as what? Alkanes. If OH is present, that guy will no longer be named as alkane, but it will be named as what? Alkanols. Right? So, alkyl groups, example of alkyl groups, please do not forget that alkyl groups are groups that contains carbon and what? Hydrogen. So for alkyl groups, we have the first one, CH3, which is what? Methyl. We have the second one, C2H5 or CH2. Please, this dash you're seeing here is their point of attachment. They are substituents, so they are meant to be attached somewhere. So these lines you're seeing is their point of what? Attachment. So this is ethyl. We have C3H7. Now this guy can either be CH2, CH2, CH3, which we're going to call propyl, or it can be CH3, which you can call 2-propyl, or isopropyl. Now, I'm going to be explaining why. The difference between both, if you notice, both of them have C3H7, but the only difference is the carbon that is being attached to the main compound. Remember, these lines are where they are attached to a compound, right? So this guy is attached to a main compound using carbon 1, using the first what? Carbon. Because if you want to number this guy, this is carbon 1, carbon 2, and what? But this second guy, this guy is 1-propyl or normal propyl. So you can either call it 1-propyl or you just call it what? This one simply means the entire C3H7 is attached somewhere using carbon what? 1. 2-propyl means that everything is attached using carbon what? 2. So take note of that. So let's do the last one, then we stop there for the alkyl. We have C4H9. Now, this guy have four different ways it can be presented. The first one is CH2, 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 CH3. This is 1-butyl or butyl. The next one is we have this is what? Isobutyl. The point of attachment is here. Now we have the C. Now this is which is secondary butyl. Secondary means the carbon in which this butyl is attached to two other carbons. This is the point of attachment of this entire group, right? This guy is attached to how many carbons? 1, 2. That's why it's sec. And the last one is tertiary. We have CH3. Now this one is terts. Please, this stuff you're seeing as sec, they can write it as S-butyl. This one that is tert, they can write it as T-butyl. So we're going to be seeing how these guys will come in exams or how it can be asked in a question. This. I didn't say second carbon. This was the one I was referring to. Is here. Carbon 1. So this is how I remember the isobutyl. I use isopropyl to remember it. Isopropyl is written as this. This is isopropyl. I decided not to put this CH3 by the side, right? So this place now, put CH2 and put line. It becomes isobutyl. Well, with time you get to know that. So let's look at halogens. We have this chloro, fluoro, bromo, iodo. And then we have nitro. So we need to know how this entire stuff, their names, so that when we want to combine it to form a name of a compound, it will make sense to us. Please, if you really want to understand how this name came about, it will throw you off balance, but I'll try, right? But just relax. Let me tell us. The first one, so let me just explain why we are calling them the normal butyl. First, C4H9 is butyl because butyl is an alkyl. Alkyl is one carbon short of alkanes, right? Alkyl is usually one carbon short of alkanes. Is it not so? Alkyl one hydrogen, have CN, one hydrogen short of alkane. So if alkane is C4H10, the alkyl counterpart will be C4H what? 9. All right. If I have CH3, CH2, CH2. If it is CH3, it would have been butane. I'll now say, now this is normal butyl. Butyl that is straight chain. The substituent is at the first carbon, is it not so? Now, normally isopropyl, from what we did previously, I said this is isopropyl, is it not so? Right? Now, I can decide to bring this guy, instead of putting it side, I put it here. This is still isopropyl. This is still isopropyl. This CH3, I bring it down, this guy, I put it by the side. It is still on this carbon. So for me to now get isobutyl, what I will simply do here is to add CH2 here. And that becomes isobutyl. Okay. Now, the next one is sec. Sec means secondary. Secondary carbon is carbon that is attached to two other carbons. Tertiary means carbon that is attached to how many? 3. So if I say 1, 2, 3, 4. 4 carbon is here, right? I come here and I make the point of attachment on this carbon. This carbon is attached to how many carbon? 1, 2. Right? So this is sec-butyl. This is sec-butyl. If I now say 1, 2, 3, 4. The point of attachment is on this carbon, right? This carbon is attached to how many? That's what? Tertiary. Tertiary can be called tet or just T. Okay, so that is that for. Number the substituent, number the parent chain. Rule number 3 says, number the parent chain from the side that would give the substituents the lowest possible number. Rule number 3, remember rule number 1 was identify the parent chain. Rule number 2 was to identify the substituents. So after you've identified the substituent, we now move to rule number 3, which is number the parent chain from the side that would give the substituents the lowest possible number. Example, I have CH3, CH2, CH, CH3, CH3. Now we have CH3, CH2, now we have two examples here. Now the first one is mono-substituted, one substituent. The second guy is di. Now, what we are going to do here is identify the parent chain. Class, before you don't use your eyes, always count from carbon to carbon. But from this guy, 1, 2, 3, 4, 4 carbon, right? 1, 2, 3, 4, 4, 1, 2, 3. So 4 is the parent chain, isn't it also? So I'll now come here. Class, once I've identified the parent chain, probably to avoid mistake, it's best you circle it or enclose it with a bracket. Now, the next thing you're going to do is, we have figured out the one that is the parent chain, and we'll figure out the one that is a branch, right? The next thing you're going to do is to number the parent chain. We have applied rule number 1, identifying the parent chain. After identifying the parent chain, we have seen our substituent, right? This substituent is an alkyl group, is it not so? Because it's comprising of only carbon and what? Hydrogen. And what is the name of this alkyl group? Methyl. So the next thing you're going to do is to count, to number this parent chain from the side that will give these substituents the lowest possible number. If I start from the left, this guy would be 1, 2, 3, position 3. If I start from the right, this would be 1, 2. So 2 and 3, which of these two is the lowest in terms of number? 2. So the correct way to number this guy would be 1, 2, 3, and what? 4. Now, although we've not gotten to, naming of the compound, but let me just show us how to name this compound. I'll say at carbon 2, I have a substituent, right? What is the name of the substituent? So this becomes 2 methyl. Now this methyl is on how many carbon chain? And what is the name of the 4 carbon chain? So this becomes, so that is the name of this compound. Now let's look at this guy. We have 2 substituents there. So this becomes 1. Okay, the parent chain will be 1, 2, 3, 4, 5. 5 carbon chain. 5 carbon chain. Now, how many substituents do we have here, class? 2. This and this is also. So the next thing we are going to do now is to number the parent chain from the side that will give the substituent the lowest number. If you come from this side, this will be 1, 2, 3, 4. These guys are carbon 3 and these guys are carbon what? So we have from the left, let's call this guy A and let's call this guy B. If I'm numbering from A, we have 3 and what? 4. If I'm coming from B, 1, 2, 3. This becomes B is what? 2 and 3 and 3 and 4. Which of these is the smallest? So obviously, which side are we going to follow? B, the side that gave us the smallest number, is it not so? So this becomes carbon 1, 2, 3, 4, 5. Now I know we have not gotten to naming this compound, but let's name it. When you're actually naming substituents that are not the same, you arrange them alphabetically. Arrange them what? F and Cl, they are under halogens, right? What is the name of F? What is the name of Cl? Chloro and fluoro. Which of them come first alphabetically? C, right? C come before F. So this becomes 2. Class, anytime you're writing number and letter, you have to separate them with hyphen. Number and letter, separate with what? 2 chloro. Now what is the name of the parent chain? Pentane, because it's how many carbon? 5. So that is that. As simple as that. Please write down. How? What don't you understand? You have to be explicit. This or this. Now, the side that will give these 2 substituents the smallest number is this side. If I start from here, this is, now look up. If I start from this side, this is 1, 2, 3, 4, and 5. If I start from here like this, the substituent is carbon 2 and carbon 3. 2 plus 3 is 5, right? But if I start from here, the substituent is carbon 3 and 4. 3 and 4 is what? 7. So between which of this side will give this substituent the lowest number? Is this side. So you follow the side that will give the substituent the lowest what? Number. Do you understand now? Please look at this. I said for multiple substituents simply means more than 2 and above. Now the last example we did here was multiple substituents, although I just named the compound without giving us a rule. So I said if they are different, if different types, that is, if we have 2 or more different types of substituents, the names of the substituents are arranged alphabetically in front of the what? Parent name. That's exactly what we did previously, where we had the fluoro and the chloro also. Now, if same type of substituent, if the substituents of the same type, the position of the substituent are separated with a what? A comma. And then di, tri, and tetra is used if same substituents are how many? 2. Like if it's repeating twice, thrice, or what? Tetra. So this is what I mean. If I have something like this, CH3, let's use this guy. Now let's do this. After this two example, we move down to the next topic. Now the first one, remember all these points represent CH3. They are carbon, right? So this carbon, 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 carbon. So here, this place you're seeing here is carbon, which is CH3. Here 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 is CH3. I already explained how this is CH3 before now. So you want to get the parent chain. Now let's start from, let's check it out. 1, 2, 3, 4, 5, 6. I'm checking all the possibilities. In as much as I already know the parent chain here, but I just want to show us that you don't just have to run into conclusion. Just make sure you check it out. 1, 2, 3, 4, 5, 6. 6 carbon. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We realize that this 8 and this 8, they are the same. Right? They are the same because two of them are on this, they're on this same carbon. So going like this is equivalent to going like this, you know so. So my parent chain is now 8 carbon, which is this guy. How many substituents can we now see there? Please, anything that is not part of that bracket is a substituent. This is not part of the bracket. A substituent. This is not part of it. And this is not part of it. Right? Are you following? You. So we have 3 substituents here. So the next thing we are going to do is that we can see the substituents. So let's start numbering this parent chain from the side that will give this guy the lowest number. Obviously, is this side. Because these substituents are closer to this terminal carbon. If I start from here, the numbers will be high. Do you agree with me that is this side? Yes. So if I start from here, this is 1, 2, 3, 4, 5, 6, 7, 8. Now the 3 substituents are carbon 2, carbon 3, and carbon what? 4. What if I had started from this side? Now let's see. This is carbon 1, 2, 3, 4, 5, 6, 7. So if I start here, these 3 substituents will be at carbon 5, carbon 6, and carbon what? And obviously they are very, very what? High. Normally the rule says sum the substituents. Listen, maybe we'll get to that. Once the substituents are much, sum it up. The side that will give us the smallest number, you follow that side. So if you follow this side, this is 2, 3, and 4. So we say 2 plus 3 plus 4. This is equal to how many? 9. If I follow this side, this is 1, 2, 3, 4, 5, 6, 7, 8. If I follow this side, the substituent is at 5, 6, and what? 7. 5 plus 6 is 11. 11 plus 7 is what? So which of these two gives us the smallest number when you add it up? 9. Right? So another way for you to know the side you're going to follow is a side that when you add up the substituent position, right? The side that will give us the smallest number after the substituent position has been added, right? You follow that side. So obviously, is this side we are going to follow? Is it not so? All right. So class, since we have 3 same type of substituents, this is what we are going to do. The rule says, if they are same type, their position number will be separated with a comma. So we'll start. The first one is at 2, 3, and 4. So this becomes 2, 3, what? 4. How many of these same type are present here? And then di, tri, and tetra is used if the substituents are what? I believe you know what this respectively means, right? If it is 2, you use what? If it is 3, you use what? If it is 4, you use what? So how many same type of substituent do we have here? 3, right? So this becomes try what? Because methyl is repeating itself how many times? 3 times. So this is trimethyl. What is the parent name here? 8 carbon alkane is octane. So that becomes the name of that guy. 2, 3, 4 trimethyl octane. Now let's look at it. Please hold on before you start writing. Hold on. So now look at this. The parent chain is obviously 1, 2, 3, 4, 5, 6, 7. Is it not so? So this becomes this is the parent chain. 1, 2, 3, 4, 5. Class. I'm numbering it from this side because I already know that this side will give us the smallest number. Because these substituents are closer to this terminal, this end. Right? Since the substituents are closer to this side, that means if I start numbering it from here, this guy will give us the smallest number. Right? Carbon 2 we have chloro. Carbon 3 we also have chloro. So since there are 2, I will say 2, 3. How many carbon do we have here? 6. Oh, thank you. So this is, see why you guys are very intelligent. So we have 2,3 dichloroheptane. So I'm thinking of, let's now look at something that is very complex. At least we have done the elementary parts. So let's include something that is complex. Let's see how it will fare. Or let's please look up. In this case, I purposely gave us this. A very simple question, but then very tactical. If you're asked to actually name this, how do we do it? Identify the parent chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. No, 4 is small. 1, 2, 3, 4. So 6 is the parent chain. I'll come here. I'll circle it. The next thing we are going to do is to number these guys. But I've already seen this compound that whichever side you're going to number it from, the substituent will have the same position. I selectively gave us this. So this is what we call the substituents are equal distance from both sides. So if I start from here, this is 1, 2, 3, 4, 5, 6. The two substituents are number 3 and number 4. If I start from here, 1, 2, 3, 4, 5, 6. So whichever side you're starting from, you're going to have same position, is it not so? So stuff like this is the substituents are equal distance from both sides. Class, in a case where the two substituents are equal distance from both sides, this is what you're going to do. You're now going to cite them alphabetically. The one that is cited first alphabetically takes the smallest number. Now, Cl is chloro, CH3 is methyl, is it not so? If I start from A, class, if I take A, this is going to be 3 methyl, 4 what? Chloro. Let's call this guy A, and let's call this guy what? B. If I start from this side, 1, 2. If I start from B is going to be what? 3 chloro, 4 methyl. If you add it up, this is 7, and this is what? Equal distance from both sides. Class, in cases like this, alphabetical order comes into play. The one that is cited first takes the smallest number. Between C that starts chloro and M that starts methyl, right? Which of them comes first alphabetically? Chloro. So therefore, anyone that chloro have the smallest number is the one we are going to follow. Please look up. I said, first, if you number this guy from this left, or you number it from the right, this substituent will take the same position 3 and position 4, right? So the big question now is, there is no, for you to be able to get the right stuff, normally you would have looked for the one that gives the substituent the lowest number, is it not so? But both sides are giving us the same number. What do we do? In this case now, you now say, which of those two substituents come first alphabetically? The one that comes first alphabetically have to take the smallest number. Because I cannot come first alphabetically and then you will not give me the smallest number, right? You only do this when both sides have the same numbering position. Is it not so? Here, C comes first alphabetically. C is having 4. Here, C is having what? So obviously, this side is not going to work. This side is going to work. So you now say, which side gave chloro the smallest number? B. So I'll now come here. This is now the side I'll follow. So I'll now follow this numbering 1, 2, 3, 4. So this now becomes 3 chloro. Don't forget, if 2 substituents are present, you arrange them alphabetically, right? Hexane. Class, one more important stuff I would like to tell us. Please listen. Whenever you're continuing alphabetical order, class, you don't consider di, tri, tetra. For example, if I have di, right? This di is not the name of the substituent. If this is dimethyl, the alphabetical order you're going to consider is a what? Because methyl is a substituent, di is only telling me that methyl is how many times? 2. Do you understand? So if you want to arrange it alphabetically, don't say, let's assume you have something like, let's say fluoro. Imagine you have dimethyl and you have fluoro. And you want to arrange this alphabetically. You will see D comes before what? F. You now come and say dimethyl, you are wrong. Class, D, yes, come before F, but in alphabetical order, you don't consider D. Because D, di, tri, they are just placeholders. They are telling us that whatever substituent that was there is appearing how many times? 2 times. So the real substituent is the what? Methyl. So this guy will now be, fluoro will come before what? Methyl. Do you understand? Thank God this stuff is recorded so that in case you say, sir, we were not taught. Let's add this. Can anybody give me the name of this guy? Well, I know a lot of persons will try, but we don't have enough time. I'm already running out of time. You have gotten it. I try. Shoot. These new ones, so have you added these 2 new ones? Please, in terms of alphabetical order, ISO is considered. I is considered, right? Because this is the name of this guy. ISO is the name of that guy. This is not a placeholder. The one that is not considered is di, tri, tetra. ISO, okay, just go ahead. Forget about the alphabetical order. The 1, 2, 3, 4, 5, 6, 7, 8. Is she correct? Class, we cannot finish nomenclature one day. I told us earlier. So once we've gotten to a particular place, I'll pause so that the ones you've learned will sink down. But if I should bombard you with everything, trust me, you forget rule number 2. Now, but I think she's correct. But let's try it out. The parent chain is this guy. That's the parent chain. Is it not so? Now, let's number from the side I'll give. First, identify the substituents. Before you start numbering, let's identify the substituents. Class, this is methyl. I believe you know that. End of line is carbon. There is CH3. This methyl and this methyl. This guy is isopropyl, which is same thing as 2-propyl. This stuff you're seeing here is more like saying CH3, which is here, CH, which is this point. That point that was attached Remember, position 2 I told us, right? This is this other guy. So this particular stuff, this CH3, CH, this is 2-propyl or isopropyl. This guy. Please, this stuff is isopropyl. Because if you interpret this from this skeletal form to normal form, this is what we are going to have. And I told us this is C3H7. And I told us that C3H7 can be in place of either 1-propyl or 2-propyl. And I say 2-propyl is also known as what? Isopropyl. All right. Okay. So at carbon, okay, this guy is methyl, this is methyl, and this is methyl, because this point represents carbon, isn't it so? So we have identified the substituent. The next thing we are going to do is to number the parent chain. Number from the side that will give the substituents the lowest.
Please look up. I was trying to explain something here. We have gotten, this is isopropyl, this is methyl, this is methyl. Now, to number this guy, obviously we're going to start from this side. Because this side, the substituents are closer to this side. Right? This side will give the substituent the smallest number, isn't it so? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, carbon 2 and 4, we have methyl. So I'll say 2, 4, dimethyl. Carbon 3, I have isopropyl or 3. Now, this 2-propyl is always together. So you have, if you use 2-propyl, you have to put inside what? You don't put inside brackets. If you do this, it does not make sense. This simply means that everything here is at number what? 3. And this top here, remember, isopropyl is as what? 2-propyl. So to avoid confusion, we can stick to what? Now, alphabetically, this is what I'm going to consider N and what? ISO can be considered because ISO, that is the name of that guy. Unlike that was just telling us how many times it is appearing. So ISO can be counted. I'm very certain about that. So N and I, which one come first? I. So this becomes 3 isopropyl, 2, 4 dimethyl nonane, and she was correct. That's the correct answer for that stuff. Any question? So with this now, we've actually done, I've given us the basis that you need for naming of alkanes. So what is left now is cycloalkanes. That one is not going to take us much time. Can we do okay, let's do bicyclo. After bicyclo, I'll end the class for today. Tomorrow we do alkanes, alkynes.